Okay, in geometry today, we're going to be talking about volume, okay, which is the cubes, so to speak, that can fit inside a 3D figure. So we talk about volume, we're talking about the amount it takes to fill something. So what are the units? Volume is the amount that it takes to completely fill something. This requires 3D objects known as cubes to fill the figure. That's why when we talk about volume, we're talking about units cubed. Area, unit squared, is flat like paper. Imagine how hard it would be, to fill something completely with completely flat paper. So something that didn't have thickness could never fill anything. So when we talk about surface area, we're talking about covering. That's why it's unit squared, because it's like taking a bunch of little squares and covering something in them. Volume is about filling something up, and you have to have something that's 3D to fill it up. So we're going to be looking at the same figures we looked at with surface area, which are polygon-based prisms. So it could be a rectangle like that, or it could also be, with example, a base and another base connected with straight lines, or it could be trapezoid, triangle, any of those things. And polygon-based pyramids. So what that means is it has a base, which could be a rectangle or a square. Most likely they're going to be a square or an equilateral triangle, and they come to a point. Also, though, we're going to be looking at our circle-based figures, such as a sphere, a cylinder, which again has a base of a circle connected by straight lines, and a cone, which is kind of like the circle version of a pyramid. Comes to a point, has a base that's a circle. So we're going to start off with the volume of a prism. First of all, volume is a lot easier to find than total surface area. From now on, I'm going to use TSA for total surface area to make it short to write. Imagine a rectangular prism made of blocks. So we start off with one little block, and imagine that we continue to sort of link these blocks together one at a time. Okay, as you can see, we end up with what amounts to a rectangular prism. The prism has a height of 1, a width of 4, and a depth of 3. Okay, so if you can't see that, it's 1 by 4 by 3. And that's kind of what we've been practicing when we talked about surface area. We talk about volume. Volume is really the number of cubes, so all I have to do is simply count the cubes. If you count them, you'll see there are 12 cubes there. Okay, well, the question is, how can we figure out a way to get that number 12 if we don't have cubes, if there aren't drawn in there like that? How are we going to figure out what the number of volume is? Well, notice that really what I have is I have the area of the base, and by that I mean my base is the 3 by 4 rectangle. Okay, that's my base. So what I've done is I've taken that and I've multiplied it by the height, which is 1. The same is true if we stack it 2 high or 3 high. So we'll start off looking at 2 high. Now, as you can imagine, what we have is we have 24 total cubes, but we also have what it amounts to the area of the base. Remember, the area of the base is 12 times the height, which is now 2, which gives us 24 cubes. Stacking it one more stack. Now we have an area of 12 multiplied by the height of 3, which gives us 36. And if we count the cubes, sure enough, it's the same. I like to think of it as stacks. So even though they're not drawn there, you can imagine on the base, the bottom, we have a 3 by 4, and then they are stacked. So our formula is area of the base times the height. And the reason we do this instead of like multiplying base times height times width is because this works for everything. Triangles, trapezoids, parallelograms, even circles. So we're going to go ahead and take a look at an example. In this case, the area of my base first of all is the 4 by 4 square. I know that because there's a base in the front and a base in the back. So what I'm going to do is I'm going to figure out what is the area of that. Well, it's a 4 by 4. So when we talk about rectangles, we can multiply the sides. And 4 times 4 gives us 16 units squared. Okay, now remember it's area of the base times height. Now a lot of times people think about height as only being something up and down. You could also think of it as width, but in my opinion, I always do area of the base times height. So what I want you to think about is instead of that length being 8, imagine that there are 8 of them in there. It's been broken up into 8 piles. Each one of them has 16 as the volume, 16 units cubed actually. So what we're going to do is when we multiply it by that 8 rows of 16, which gives us 128 units cubed. And all I did there was take 16 times 8. So the key, I think, is to identify your base. If it's a triangle, identify the triangle base. If it's a rectangle, identify the rectangle base. Trapezoid, circle, etc. Okay, here again, now we're going to do another example. Take a second and try to figure out what you think the base is. And once you figure that out, try to figure out the area of that and then multiply it by the height. So I'm going to have you pause it completely on your own. Find the area of the base, multiply by the height. All right, so in this case, my base is that triangle. The rule for the base is that it has to be the same shape connected by straight lines. So really, even though there are 3 rectangles going on here, they're not connected by straight lines. They're connected by angled lines, and in addition to that, they're not the same size, so they're not exactly the same. Well, the area of a triangle is base 1 plus base 2. Remember that on a triangle, base 2 is 0, so it's going to be 3, which is the height, times 4 plus 0, all divided by 2. 3 times 4 is 12, and 12 divided by 2 is 6 units squared. So now we have the area of our base, and now we imagine it being 4 stacks of them. Okay, so for each one, it's 6 units cubed, and I'm going to have 4. 4 times 6 is 24 units cubed. Biggest thing to remember, we're talking about volume. It should always be cubed. Centimeters cubed, inches cubed, units cubed. It's always in the third power. Next, we're going to be talking about volume of a cylinder. The reason I skip from prism to cylinder and skip over pyramid is because the cylinder is exactly like a prism. The only difference is the base is no longer a triangle, a trapezoid, a parallelogram. It's actually a circle. So what that means is I've got my area of my base, which is a circle. We know the area of a circle is pi r squared. And we know our height is h. So in this case, all I'm going to do is just like the other ones, I'm going to take the area of my base multiplied by the height. Let's look at an example together. First off, we're going to take the area of the base. Our base is a circle with a radius of 3. So 3 times 3 times pi gives me 9 pi units squared. In addition to that, I'm going to multiply it by the height. So I want to imagine breaking this up into 6 sections. And 9 times 6 is 54 pi units squared. Notice that I have pi in my answer here. If we're talking about things that involve circles, there should always be pi. If I'm not talking about things that have circles, there should not be pi. That's a big one too. I end up having students just throw pi symbol on everything. That doesn't make sense. You can only do that when you're talking about circles because that's what the formula calls for. Okay, second example, I want you to go ahead and try to do the whole thing on your own. Remember, you don't have to draw in all of the arches. That's kind of difficult to do. The key is to remember that you're just doing area of the base times height. All right, so what we're going to do is we're going to find the area of the base. The base is a radius of 6, so it's going to end up being 36 pi units squared. That's the area of the base. That's why we're talking about squared, because we're talking about area. Then what we're going to do is we're going to multiply it by the height of the figure. The height of the figure happens to be 12, and 36 times 12 is 432 pi. Well, those are fairly obvious. I think the pyramid and the cone have their own kind of special twist. And what that is because they go to a point, it's not just simply area of the base times height. You can't imagine them being stacked like that. Okay, so we're going to start off looking at the volume of a pyramid and something interesting about it. And here's the deal. Even though it looks like probably maybe 2 of these would fit in a prism of the same size, the reality is that it actually takes 3 of the exact same height and base area, exact same base and exact same height, to fill a prism of the same size. So the interesting thing is it would take 3 of them. Why is that important? Well, if we think about the volume of a prism, all we do is we take the area of the base and times it by the height. Well, if we talk about pyramids, it's 1/3 the size. So we're going to go ahead and take the area of the base, times it by the height, and then cut it into 1/3, meaning divide it by 3. And that will give us the appropriate volume. So first of all, this is a little short video you're going to see. And in this video, they're going to show you proof of the fact that it takes 3 pyramids to equal 1 prism of the same size. So as you can see, he has a prism that is the exact same base area and the exact same height as the pyramid. So what he's doing here is showing you, yes, the area of the base is the same. If it was any different, it would either fall in or be too big. Okay, now what we're going to do is, this is demonstrating the height. Now what we're going to do is we're going to go ahead and he's going to fill up the pyramid and show that it takes 3 full pyramids to equal the same amount of volume that is in the prism. So as you can see, he's going to go ahead and fill up his first pyramid of liquid. Okay, so he's going to start with his first one. Okay, as you can see now, he's done 2 of them. And we're not all the way there yet. And of course, the last one is giving you a full prism. So again, it takes 1/3 to fill that, or another way of looking at it is it takes 3 of those to fill a prism. So let's go ahead and take a look at how we go ahead and find that volume then. What we're going to do is, since the volume, it takes 3 to fill 1 prism, if we want to have just 1, it would be 1/3 of the area of the prism. What that means is we're going to take what we did before, which is area of base times height, but this time we're going to divide it by 3 because it takes 3 of them to fill a prism. So let's try a few examples. We're going to do the first one together. So the key here is to make sure you understand that you have to have the height as well as the base. So the biggest thing is, a lot of times they'll give you the slant height, which looks something like this. And you have to be careful because that is not the height of the pyramid. It's actually longer, and also it's something that you're going to need to figure out the height if they don't give it to you. So in this case, we're going to start off with the area of our base. Our base happens to be a square with sides of 5, so 5 times 5 is 25. We're then going to take that and we're going to multiply it times the height and then divide it by 3, which equals 100 units cubed. Okay, so I want you to try this example on your own. So pause the video, take a second, it's a lot like the last one, and hit play when you're done. All right, so what we're going to do is we're going to start off with the area of our base. Our base is a square. That means 6 times 6 is our base, which is 36. We're then going to take that, we're going to multiply it by the height, which is 4, and divide it by 3. 144 divided by 3 is 48 units cubed. Okay, now this one is an equilateral triangle base pyramid. First of all, we need to know the area of the base. I went ahead and gave it to you because if you do not know how to find it, you cannot find the area of a triangle. So in this case, we were not given the height and given the base, so we can't actually find the area of it. So in the problem, I gave you that the area was 12 units squared. Now all we have left to do is multiply it by the height and divide by 3. So we're going to end up with 12 times 5, which is 60, divided by 3. That simplifies to 20 units cubed. Okay, now we're talking about the volume of a cone. This rule follows exactly the same as a pyramid. It's a short video to kind of show you what we're talking about here. That in fact it does take 3 of the cones to equal the volume of one cylinder of the same base area, which is the circle, and height. So I'm going to kind of fast forward here so you can see. Using a green liquid this time, it's 1/3, 2/3, and 3/3. So clearly each cone equaled 1/3 of the cylinder. Okay, so let's try an example. We'll do this one together. First, we're going to start with the area of our base, which is 5 times 5, which is 25 pi units squared. We're then going to use the height of the figure, which is 9, and then at the very end, divide by 3. You may want to ask yourself at this point, do I know why I divided by 3 there? Because that's a very important part to get out of this lesson. The key is, if it goes to a point, then you're going to divide by 3. If it doesn't go to a point, then you're good to leave it as is. Our final answer here is 75 pi units cubed. Okay, so go ahead and try this one on your own. Hit play when you're ready. Okay, so let's go ahead and get started. We're going to start with the area of the base. The base is a circle with a radius of 9. So 9 times 9 is 81 pi units squared. We're then going to multiply that by the height. 81 times 10 is 810 pi units cubed now. And we're going to divide that by 3 because it goes to a point. 810 divided by 3 is 270 pi units cubed. Okay, lastly, we're going to look at the volume of a sphere. We look at it separately because it's kind of different than everything else. First off, let's look at the formula. Well, when we have a sphere, the main thing and the only detail is the radius. The deal is the volume of a sphere is equal to the surface area of the sphere divided by 3. Kind of. I mean, the formula is 4 pi r squared, and the formula for the volume is 4 pi r cubed divided by 3. So it's close. Volume is 4 pi r cubed over 3. All right. So we're going to watch again a short video here. In this video, they're going to demonstrate something, and then I'll explain what they're demonstrating. The key is that the volume of a sphere will fill up 2/3 of the volume of a cylinder of the exact same width, meaning I should say diameter or circumference. It'll fill up 2/3 of that, which I know is not the formula, but we're going to be taking a look at why that equates to the formula we're looking for. So as you can see, he's going to fill up the cylinder. Sorry, the sphere. He filled up the sphere, and now he's going to pour that into the cylinder. And what we're going to see is that it takes up 2/3 of the cylinder's volume. Okay, as you can see, it pretty much perfectly fills up 2/3. So what we're going to look at now is why that is. So let's start with the volume of cylinder. The volume of cylinder is pi r squared times h. We know that formula. Here, though, because we're talking about a cylinder that is the exact same size as the sphere, okay, what we have here is we have our cylinder, and inside there fits a perfect sphere. So when I think about the height, really what I'm looking at is the height being halfway across the sphere and then again halfway across, which is where the 2 radius comes from. Because on that sphere, if I want to look at the whole distance from bottom to top, it's not the radius. I have a radius going up, and then I also have a second radius going down. So really what happens is the height ends up being 2 r's. Simplifying that out, you end up with 2 pi r cubed. Now, when I take a look at the volume of a sphere, I'm looking at the formula that I know to be true, which is 2/3 times 2 pi r cubed. Why? Because we just showed that it filled up 2/3 of the cylinder. So if the volume of the cylinder is 2 pi r cubed and the sphere filled up 2/3 of it, that's what we have right there. When we multiply 2/3 times 2, you get 4/3, which gives you the formula that we know to be the volume of a sphere. So now we're going to go ahead and try a couple of examples. All the information you need is right there in the radius. And we're simply going to go ahead and plug it right into the formula. 4 pi r cubed divided by 3. going ahead and plugging in. The hardest part about this is using a calculator to calculate the large numbers. So we end up with 4 times 216 pi, which is 6 times 6 times 6, and then divided by 3. When we simplify that, we're going to end up with 864 over 3, which is 288 pi units cubed. Okay, so go ahead and try the second example here. See if you can get the whole thing done. Okay, so we're going to use our formula again. 4 pi r cubed divided by 3. 3 times 3 times 3 is 27. And 4 times 27 is 108. 108 divided by 3 gives us 36 pi units cubed. So we have to remember, very important, we have to remember that we have to divide by 3 when it's a sphere or it goes to a point. That's the key. So at this point, we're finished with the video. There was one on surface area, and now this one's on volume. So what I would like you guys to do is just make sure you're practiced and prepared for the quiz we're going to have in class later, and to have classroom discussions about these topics.